This is what we had looked at in our previous video, and we want to concentrate now on the normal curve. So let me just change this to the normal frequency curve. That's what we want to look at now. Let me just erase the rest of what I had here before. Get rid of this. Alright, we're going to redraw the normal curve. I want my graph paper to be a bit larger. Alright, now the thing is, what could possibly give rise to this normal curve? Let's see a possible example. Let us say that you have a large number of persons and you measure their height. Let's say at the center you have 5 feet 7 inches, 4, 3, 2, 1, and this is 5, 6, 5 feet 6, 5 feet 5, 5 feet 4. I'm just separating the feet and inches by comma. 5 feet 3, 5 feet 2, 5 feet 1, 5, 4, 11, 4, 10, and you go up to 5, 8, 5, 9, 5 feet 10 inches, 5 feet 11, 6 feet, 6 foot 1, 6 foot 2, 6 foot 3, 6 foot 4. All right. Now you have thousands of persons. All right, say 1,000 persons. Go up to 1,000. You don't really have a lot of persons who are as short as 4 feet 10. So let's say you start here. 4 feet 11, you have a few more. 5 feet goes up. 5 foot 1, 5, 2. It probably wouldn't rise that fast. Say 4 foot 1, 4 foot 11, 5 feet, 5 foot 1, 5, 2, 5, 3, and 5, 4, 5 feet 5, 5 feet 6 inches. You're finding a lot more persons, 5 feet 7 inches. And that's the average height. Then 5 feet 8, going back down, 5 feet 9, 5, 10. Persons getting very tall now. Alright? 5, 11, 6 feet, 6 feet 1 inch, 6. I'm moving down a bit fast. It wouldn't, I don't think it would go back down this fast in reality, but probably yeah. 6, 1, 6, 2, 6, 3. Alright, just for argument's sake, we have this curve, and then we have these dots or these markings or plottings, and we draw a curve like that. Alright, you get the general shape of a normal curve. Not well, far from perfect, but you get the idea. And the average height is 5'7", so the average is at the center. You have one extreme and another extreme. If you should have gone, say 4 feet 9, 4 4 feet 5, 4 feet, 3 feet odd, it would have gone way down very fast. And you went above 6 foot, 6, 5, 6, 6, 6, 7, you don't have a lot of people who are that tall. But the bulk of the persons are here in this region near the center. So that's the idea behind what is called a normal curve. That's one way of getting a normal curve. Maybe when it comes to height, probably I'm thinking that the height of persons may not be the perfect example, but it gives you an idea. It may not be the perfect example for a normal curve. Probably you don't have a lot of people above 6 feet. It will come down very quite rapidly, all right? But it should be close. It should be close. Now, intelligent quotient, that is one using normal curve. That is one distribution that gives a normal curve. Examination scores, that is another, right? So you have various situations that you can look up and you see all sorts of situations that can give a normal curve. In fact, some statisticians say, well, generally they say that once you're studying 30 or more samples, persons, whatever the case is, then it kind of approach the normal curve. Once it goes above 30, you start to approach the normal curve. All right. Now, of course, you have various parts of the normal curve which we will talk about at a later date in further videos, right? But this was just to give you an idea what could possibly be responsible for causing this normal curve. It's just that on the left, at the lower extreme, you don't have a lot. On the right, at the upper extreme, you don't have a lot. But in the middle, you have a bulk, the bulk, right? Bulk of persons, or the bulk of items, or the bulk of the measurement. And in the middle is the mean, the average. So basically, to the left, it covers 50% of the sample. To the right, it covers 50% of the sample. So everybody gets accounted for, and it reaches 100%. All right. This number, it could be 1,000, it could be 10,000, a million, whatever the number is, if you have all of that time to study a million people. But here, as I said, you have from one extreme to another, you don't have a lot of samples of measurement, but the bulk, of course, would be crowded in the middle, at the average. Alright, we'll examine this in more details in later videos, so I will see you then.